Now let us discuss the 75. What is the correct electronic configuration of the center metal atom in K4 FeCN6 based on the crystal field theory? According to crystal field theory, what is the electronic configuration of a central metal atom? That is ferrous. Write the given complex K4 FeCN6. Now let us try to calculate the oxidation state of ferrous. Okay. Here you observe that 4 moles of K. That means K exhibits the plus charge. To neutralize plus 4, you have to add minus 4. Then it becomes FeCN6 4 minus. Here you have to calculate the oxidation state of central metal atom, that is ferrous. It considers an X plus 6 into the charge of Cn is minus 1 equal to 4 minus. Here X minus 6 equal to 4 minus. Then X equal to 6 minus 4. X equal to plus 2. Here we find out that oxidation state of central metal atom, that is ferrous, is plus 2. You know that ferrous atomic number is 26. Its electronic configuration is argon 4s2 3d6. Now let us write the electronic configuration in Fe plus 2 oxidation state. Its electronic configuration becomes argon 4s0 3d6. Now let us see the splitting in crystal field theory. These d orbitals are split to form EZ and T2Z. Here there is presence of 6 electrons present in d orbitals. Here 1, 2, 3, 4, 5 and 6. Due to the presence of strong ligand field, these 6 electrons are paired off in T2Z orbital only. Why? Because Cn minus is a strong field ligand. T2G6, Eg 0 electrons. So 2 is our correct answer.